To solve this problem, we have to understand the question. So here is the water-filled well. Diameter is 4 meter and the height is 10 meter. A pump power of 6.87. So this is the pump, and the power, let's say this is P1, 6.87 horsepower, is used to empty the well in 20 minutes. However, after pumping out half of the water, the pump breaks. So, half of the water pumped by the very fast pump, and afterward, this is not workable. So, if it is zero height and up to this one is half of the total height, so it means this is 5 meter, right? And after then this is not workable, and then another pump need to be used to empty the remaining water within the remaining time. How long the very fast pump work? So indeed the very fast pump worked for, let's say, T1 time that we have to calculate, and P1 is equals to nothing but, in horsepower convert to watt, is 5125.02 watt, and here the effective height H is equals to how much? So here H means, so half of the well empty, so half means 5, so the effective height will be up to this much, right? Up to this much means effective height, let's say H, this is actually effective height for very fast pump, so 5 plus 0 over 2, so the effective height will be 2.5 meter. So calculate the time. We have to calculate the work done by the very fast pump. Indeed, we have to calculate the mass of the half of this well water. Indeed, we have to calculate the volume of the well. So pi r square h, and here are also given, which is diameter is 4, so r is 2, so pi 2 whole square, and h is 10, right? So the volume is 125.664 meter cube. So m is equals to rho v, so it will be multiplied with 10,000, so 125.664 times 1000, so very straightforward, 125.664 kg. This is the total water within the well, so half water have taken out, so m1 is equals to half of this amount, so it will be 62832 kgs of water, half of the well. So P1 is equals to W1 over T1. So what we have to calculate? We have to calculate the time period taken by the very fast pump to empty the half of the well. So T1 is equals to W1 over P1. So here M is 62832.9.8 and the effective height is 2.5 and P1 is 5125.02. Let's calculate. So the time is, of course, in second. So this is 300.366 second, or in minute is 5.006 minute. So the very fast pump need to work within 20 minutes, but it actually worked for 5.006 minutes and afterward it broken, right? And then second pump need to be introduced, and now it's time to calculate the power of the second pump, and let's compare with the very fast pump. So as I said, the total time need to empty the whole well is 20 minutes. How much time it worked? That is 5.06. So this one minus 5.006 minute. So 14.994 minute remains, right? So remain water, let's say M2. So half water of the well is 62832 kgs. So remain half water also this amount of kgs, right? So M2 also 62832 kgs. So it will be 62, how much? 62832 kgs. So for second pump, this one, so here is 5 meter, right? So 2 and this much is 10. So effective height for second pump need to be somewhere here, right? So indeed, what you have to calculate, the effective height H2 is equals to 5 plus 10 over 2, and that is actually 7.5 meter. So all the data we have got right now to calculate. Okay. So P2, the second pump, W2 is equals to T2. So this is the value for actually T2. So W2 is nothing but M2, G is same for every case, and this is actually H2 and over T2. Now plug in all the value we have got. So this is how much? Let's copy the value, 623. So this is 62832 kgs, and this is 9.8, and height is 7.5, the effective height, and T2 is how much? 14.994. So it will be 14.994. Let's convert into seconds. So 60 need to be multiplied with the 14.994 minutes. So what we have got, the value that is actually 5133.32 watt. The very first pump, which actually worked for 5 minutes, more than 5 minutes actually, that was 5125 watt, and in horsepower it was 6.87 horsepower. And this is the second pump, that is actually 5133.32 watt. So it was 5125.02. So the second one is slightly bigger actually in power, almost similar, right?